In question number 18, we are given that the potential difference between the terminals of a 6 volt battery is 7.2 volt when it is being charged by a current of 2 ampere. What is the internal resistance of the battery? This is a real life problem, and although the problem itself is very easy, I wanted to tell a few concepts in charging versus discharging of the capacitor. So a battery, this battery itself is 6 volt, and all batteries have an internal resistance, a very small resistance, typically very small resistance, maybe 1 ohm or less than 1 ohm, depending upon how good is the battery. So if you, and then you don't measure the voltage here at the battery itself, you measure the voltage at the terminal of a battery, and then the terminal of a battery includes that resistor. If you measure the voltage of the battery in open circuit, then the resistance, there is no flow of the current, and at that time the voltage measured will be very close to to the voltage of the battery, 6 volt, because the voltmeter itself has a very, very high resistance, and there will be almost no flow of the current in the circuit, and then you will get the true voltage of the battery. But if you measure the voltage of a battery in two different cases, it will be different from the voltage of the battery. One case, in this case, we have an external charger. I call it the external battery B. And we have connected it to the terminal of the battery, so the battery starts charging the battery. In other sense, the current starts flowing in this direction, like this. And the battery voltage starts increasing. What it means is that this voltage right here is going to be higher than this voltage, because only then the current will flow in this direction. So what it means is that if we want to find out the voltage across the terminal while in the charging process, we will have this voltage V 7.2 is equal to this battery voltage plus the drop of the across the resistor, which is 2.0 into R. And from here we can calculate the value of R. 7.2 minus 6 is 1.2 divided by 2 is equal to 0.6. Now the problem is solved, but I wanted to tell another scenario where, let us say, we remove this battery B here, which is charging this 6 volt battery, and connected a resistor here. So what happens is the current starts flowing from the battery to the load. What it means is that this is the terminal of the battery, then this voltage right here has to be lower than the voltage that is here, because only then the current will start flowing here. So if we apply the Kirchhoff law in that case to find the voltage across the terminal of the battery, V will be 6.0 minus IR. So this voltage would actually be less than 6 volt if we measured it. So depending upon if you are charging the battery or using this battery to make a current flow in an external resistor, the voltage across the terminal will be higher or lower.